Welcome to a session on logic gates. In this session, we'll see about the different logic gates and their characteristics. A logic gate is a physical device which implements a given Boolean function. Logic circuits can be classified into sequential and combinational logic circuits. A combinational logic circuit implements a Boolean function, and at any instant of time, its output depends only on the current inputs. A sequential logic circuit depends on the present and the previous inputs. As shown in the figure, the M output variables of the combinational circuit are dependent only on the N input variables. It need not wait for the previous state. So, a combinational circuit does not need memory, whereas a sequential logic circuit needs memory to store the previous state's information. Logic gates can be classified into basic gates and universal gates. And, or, and not are the basic gates, and NAND and NOR are the universal gates. They are called universal because any digital circuit can be implemented by these two gates. We'll start our analysis with the first basic gate, the AND gate. The symbol AND table of the AND gate are shown here. Now have a look at the truth table. A and B are the inputs and C is the output. Look at the first row of the truth table. A is 0, B is 0 and C is 0. In the second row, A is 0, B is 1 and the output C is also 0. The third row, A is 1, B is 0 and the output C is 0. Fourth row, both A and B are 1s and the output C is also a 1. Now have a look at the output column C. C is a 1 only for the last row. So can we conclude that in an AND gate, the output will be 1 only when all of its inputs are 1. Now for the second basic gate, the OR gate, the symbol and truth table of the OR gate are shown here. Have a look at the truth table. The output C has a value 0 only for the first row. For all the other rows, it is a 1. So consider the first row. In the first row, both the inputs are 0. So can we conclude that the OR gate gives an output 0 only when all its inputs are zeros, and even if only one input is a 1, the output C will be 1. Now for the last basic gate, the NOT gate, look at the truth table. Input is A, output is C. When the input is 0, output is 1. And when the input is 1, the output is 0. This is why the NOT gate is also called the inverter. The next set of gates are the universal gates. The first universal gate is the NAND gate, the symbol of which is shown. The symbol has the symbol of an AND gate with a bubble at the output. This says that the NAND gate is an inverted form of the AND gate. So the output expression is also Z is equal to expression of the AND gate, the whole bar, which is nothing but Z is equal to AB, the whole bar. The truth table of the NAND gate is shown. When you compare this with the truth table of the AND gate, it's very clear that the output expressions of the NAND gate are the inverted forms of that of the AND gate. We'll see about the remaining gates in the next presentation. Thank you.